Hey, what is up, guys, and welcome to the 15th day of Integral a Day. So here we have our integral. Ooh, I don't know how that happened. So we have this function L of x, and we're integrating that. Sine cube x. Now, once again, since I am actually needing to get a lot better at my trig identities, and there's something like, to my understanding, you need to look up. I've actually figured this out before the video, and now I'm just showing you guys how I did it, just in case you guys have a better way of doing it, or you guys just need a bit of a reference to go off of while figuring out how to do it. However, yeah, we have two trig identities here. Well, this is our integral, and effectively what this shows is that we can rearrange this here, this function here, so that we can get it to like a trig identity we know, so that we can make it simpler to integrate. It's something easier to show. So for example, here, the trig identity I learned today, or a trick I learned today, is you go sine squared x cos squared x. For some reason we don't yet to learn this. Please let me know in the comments if you do know, but we don't like odd numbers when integrating trig identities in the powers. Heard that in the video, but effectively now we have sine squared of x, cos squared of x, and sine x. And how we have this trig identity, yeah, that pretty much says that we got sine squared x plus cos squared x is equal to 1, which can actually be rearranged so that we can actually say, if we have sine squared of x, we can actually say, well, that's equal to 1 minus cos squared of x. And how this is useful for our integration is now we can here. So now I'll work on one thing at a time. So 1 minus cos squared x, and then we have cos squared x. Sine x is still there. Dot dx. And effectively what we can say here now is, like this here, if we make this our u, we can integrate this using u substitution to get a sine, which gets rid of our sine term here, which makes it easier to integrate then. And from there, like, well, as we know with u substitution, we use that in order to, well, how I've learned to use it at the moment is to make it simpler for us to see and integrate. So effectively what we can say is, well, if we make like u cos equal to cosine of x, then what we can say here is, well, du here can equal, well, we're integrating this here, deriving it, which, well, let's bring the negative on this side, which just leaves us with a positive sign. If it was negative sign, I don't think we could cancel it, but we'll bring the negative over here, so we're just left with sine dot dx. And as we can see now, we can actually say that dx is equal to, dx is now equal to negative du over sine x. Now we can do whatever we like with that negative sign here, but effectively what I'm showing is that we can now go 1 minus cos x cos squared x, and then we have sine x here. Oh, my bad. No, now we're writing it in terms of u. So we have 1 minus u squared was cos here. We made cosine equal to u. So now we're putting this back in. Cosine here was squared, so we've got to keep the squared. And now we can go u squared. Yeah, and well, u isn't equal to sine, so sine stays the same. And that's with respect to x here, which is actually what we want, because we want to get rid of all our terms that will have x in it. And that's why we just wanted to get it to the point where we just had like cosine here, because then we can make cosine equal to u, then get rid of the one variable or trigonometric identity that doesn't have the u in it. There's sine is we have the x in there, so we can put dot du in there. And we can't forget that since we have the negative there, we need to carry that across. But since that's like a -1, we'll just bring that out the front here. Equals negative, yeah. And now all this, remember it was du over sine x. And we can do exactly what we wanted. This is why I'm saying it's so important to know your trigonometric identities, because now we can rewrite this so that this, now that we're integrating this with just with respect to u, it's become a lot easier. So now we're just integrating this here, and we can actually make this even easier for ourselves by bringing I think that's expanding it. So, in fact, I'm not even going to put it in brackets anymore. We'll just have u squared. Since we have a minus here, thinking. No, that won't change anything. So we'll still add u for so we're integrating this here now with respect to u, which will equal, well, we raise the power as we've done the reverse power rule for integration in the past videos. Keep forgetting that negative sign. Fact here, yeah, by integrating this here, we'll actually end up with a plus u5 over 5. My bad. We're integrating now, so we don't need that. Okay. Negative that plus this plus c. And what answer? Oh, yeah. Just about to check my answer, and I was like, oh, it's a bit different. I got earlier today, but that's just because we have to substitute u back in. So our answer ends up being negative. Well, what was u? Cos. So negative cos or cosine. We'll put the cube there. Over 3 plus cosine 5 x over 5 plus c. And I believe that is our right answer here. Let's just double check it on Symbolab anyways. I got this question here, or I was looking at questions today on a website, and this one was particularly helpful and taught me a bit. So we'll use this one. So we need Symbolab. Am I still sharing the right screen? Yeah, I am. So calculus, integral, sine. Actually, I find Symbolab likes it if you write it like so, like if you break it up for it. It always, I find it spits out different answers. However, this here is the correct answer. I just don't want to run the risk. Oh, okay. Nice. All right. So I like how that looks a lot better. So they just went the extra step further, which depends on your preference. However, this here can equal 1 on 3, negative 1 on 3 cos or cosine 3. Ah! Cosine 5 x plus c. And there we have it. So that is our answer for today. Good work if you got that right. Let me know in the comments if you have an even better way of solving this, or if you actually use different trig identities in there, and make sure you tell us what trig identity you used. I'd be interested in hearing them and would like to grow as well from this video and question again. So yeah, hope you all have a lovely day or night, depending on where you are, and I'll catch you all here for day 16 tomorrow.